with a live help session on algebra. And before I get started, in the future, if you're watching one of our help sessions live, here's a few ways you can submit some questions. We have a Twitter account at Tutor Tonight. Facebook page is facebook.com/tutortonight. You can go straight to the website, tutortonight.com, and there's a chat box there where you can submit a question. We also have a small Android app. If you just go to the app section of the Google Play and type in Tutor Tonight, you'll see the little icon that looks like a moon with a graduation hat on it. That would be a good way to submit quick questions when we're not live, if you need someone maybe to answer a quick question. Anyone else that's downloaded and installed the app can answer questions there. So what I was going to go through tonight is a couple of things to help with quadratic equations. That's one of the more common things that come up in algebra is how to solve quadratic equations. So it's the end of the year, and a lot of students are probably getting ready for a final test, and that's probably one of the key things that would come up. So just wanted to go through a couple of things maybe to keep in mind that would help with those kind of questions. So just to get started, get my pen ready. Let's see. So just in case, just so we are all on the same page. So like a general form of a quadratic equation might look something like this. And so usually on a test, teacher might ask you to factor that or find its roots. That's another way they'll phrase the question, or something to that effect. And what the reason they phrase it that way is if we look at a physical depiction of the curve, if this is the y-axis, and this is the x-axis, usually what a quadratic equation is describing is some arc-looking shaped curve. And when they talk about the roots, what they're referring to is these points where the curve passes through the x-axis. And the reason there's two of them is because this is a quadratic equation, because it's squared. That helps you understand how many times you might expect it to pass through the x-axis that way. And then you'll also hear sometimes another thing that helps describe the equation is whether the curve is facing up or down, whether it's concave up or concave down. That's determined by the sign of this first coefficient. So if you were given an actual number here, let's say you were given 3 there, and it was positive, then you would know that your curve should be similar to the one I've drawn here. So sometimes a teacher might ask you to sketch out the curve, right? Well, if your equation started with some negative number, say -3, then you would expect it to be the other way. So that's another thing to keep in mind, kind of question that might come up. So what I'd like to do is just go through a couple of the ways you can solve an equation or find the roots, however you want to phrase it. So let me clear the page real quick. And let's just go through a couple of ways you can do it. The most common way you'll hear people refer to is factoring the equation. And what they mean by that is looking at the equation and trying to figure out those two numbers we were just speaking to that go through the x-axis. So let me give an example of that real quick. So let's say the teacher gave you on the test something that looks like this. And we said we know because it's a quadratic equation and it's squared, we expect to have two roots. So you've probably already discussed in class having two factors, two roots. And hopefully you remember that since we're saying it's equal to 0, that tells us, and that's, what I just physically drew, that's due to the fact that it's crossing through the x-axis. So we know there's two roots, and that one of them, if it's 0, since it's being multiplied by the other, the whole thing would be 0. So one of these can be 0, the other one can be 0, or they both can be 0. Let's assume one or the other for now, just keep it a little more general. So what we're trying to do is we're trying to break this top equation up and think through what would give us this. So if you look at this particular equation I wrote here, you see that both of these terms have negatives in front of them. And that tells you a couple of things. You may recall from just earlier classes you've taken in math that a minus times a plus is a minus. Now minus times a minus is a plus, right? You may recall that. So what that tells us about this equation is a good expectation would be of the two roots, one is most likely negative and one's most likely positive. And the reason I say that is this constant here has a negative sign in front of it. Well, in order to end up with a negative number, you would have to have a positive number times a negative number. Because if not, if they're both positive, I should have included that one, then you would expect it to be positive. So we can rule that one out. If they're both negative, it would be positive. Well, ours is negative, so we can rule that one out. So that just leaves negative times positive equals negative. So that means we should expect one of these to be negative and one of these to be positive. So we know that. So let's look at the number 10 and think what two numbers that we could multiply together would give us 10 that if we add them in some way would give us a negative 3. Well, 5 times 2 is 10. Sorry, that's supposed to be a 1. But ours is a negative 10. Well, negative times positive is a negative. So we have two options. It could either be negative 5 times positive 2 is negative 10, or it could be a positive 5 times a negative 2 is 10. Well, so now we need to figure out which one of these is right for us. Well, the way we do that is we look at this negative 3 here and we say, well, if I end up with a negative 3, that means when I add these two terms that get multiplied out, and I'll show what I mean by that here in a second, we end up with negative 3 instead of a positive number. Meaning, in other words, if I add 5 and negative 2, I would end up with a positive 3. But if I add negative 5 and a positive 2, I end up with a negative 3. So my best guess is that the negative number here is larger than the positive number. So I'm going to take my best educated guess that these are the way the roots are going to be based on what I just kind of talked through. And then we can check that by multiplying out the two terms. So x times x is x squared. Negative 5 times x is negative 5x. Negative 5 times 2 is the negative 10. And I forgot one at the front part. I did x times x is x squared. I forgot this one, sorry. So x times 2 is plus 2. But it doesn't matter the order we write them, so that's okay. We can fix it. Equals 0. So if I clean that up, I end up, I'll write it here at the bottom. I have the x squared, negative 5x plus, so if I take my negative 5x and combine it with my positive 2x, I end up with negative 3x. And then the negative 10 remains, it doesn't go anywhere, equals 0. So that's the way to check that we got it right. So based on that, what that tells me is that these are the two factors that would solve the equation. So that means I need to check two things. I need to check what would make this term 0 and what would make that term 0. Because as I said earlier, one or the other needs to be 0 or both. So x minus 5 equals 0. What would make that be true? That would be true if x equals 5, right? 5 minus 5 is 0. What would make the other one 0? X plus 2 equals 0. Well, negative 2 plus 2 equals 0. So that means the other one is negative 2. So that tells us our two roots would be 5 and negative 2. So that's what you'll commonly hear people refer to as solving it by factoring. Let's look at another example. It might look a little different to you. Sometimes you don't get it nice and neat where it's matches the standard equation. Sometimes the teacher might give you something that looks like this, where you have a number in front of the x squared, and you have that term, but maybe there's no constant. Well, this one can be a little confusing because the methods we just applied don't seem to work, but if you look at it for a second, it actually does. It just is in a slightly different form. If you look at this term, this constant, and you look at this constant, 20, they're both divisible by 5. And then they both have an x in them. So these two terms both share something. They both share 5x. So if I take 5x out of each of these, 5x, what does that leave me here? If I take 5x out of this, it leaves me with x. If I take 5x out of here, it leaves me with a negative 4. And then the right side stays 0. And we can backtrack and check ourselves. 5x times x is 5x squared. 5x times negative 4 would be the same thing as negative 4 times 5 times x, so that's negative 20 times x, so that works. Well, the same thing we did before is true. In order for what's on the left-hand side to equal 0, one of these has to equal 0. They both could equal 0, but we need at least one to equal 0. So 5x equals 0 if x is 0, and x minus 4 equals 0 if x is 4. So in this case, our roots are 0 and 4. So it's the same kind of method. We're still factoring, but it just looks a little different. So it's a different kind of breakdown, I guess is one way to think of it. So that's one thing that will trip you up sometimes. So in this last example, I mentioned that it didn't really match the standard form that we're used to seeing. And there's another method that I'd like to share with you that you may have heard of, or you may have seen, and we can review it. It's called completing the square. And let me go to an example that demonstrates that method. So let's say a teacher gave you this equation. Well, if we look at this number and this number, they don't really do what the first one did for us. There's not really a direct correlation or a connection, meaning 2 is smaller than 6, so I can't really break down 2 in any way that gives me, what 6 might be made up of. In other words, 6 is made up of 2 times 3, but that doesn't really help me here yet, right? Because 2 is smaller than that, so I can't really make use of that to make a connection and do the same kind of factoring we did before. But let's build on what I just wrote here. 6 is 2 times 3. What if we allowed ourselves to manipulate the equation? We all have heard that if you start with something that's equated to something else, you're allowed to make changes as long as you make the same change to both sides, and then it's still equal. So let's make use of that. What if I was to say x squared plus 6x, and then what if I was to make use of these two numbers here, that 6 is made up of 2 times 3? Well, what number could we, I want to say this just the right way, how could we, let me say it a different way, how could we end up with 6x? Or a better way to say it is, what constant number could I write here that if I broke it down and then did the factoring that we did a moment ago would multiply out and end up with 6x? Well, another way of thinking of 6 being 2 times 3 is 2 threes, meaning 3x plus 3x, right? Well, if we're going to do that, then that would tell us, that kind of hints what this constant should be. If this constant was 3 squared, and then we did our factoring, oh, sorry. Let me scroll back up. Going the wrong way. There we go. If I do my factoring I was showing a moment ago, oh, somehow I've managed to click and change the color of the pen. Let me fix that. There we go. Maybe it'll make better sense if I go ahead and write out the factors like I did earlier. So let's see what this gives us. What would happen if we used that? If I multiply it, x times x is x squared. X times 3 is 3x. 3 times x is 3x. 3 times 3 is 9. And if you look here, that's really what I've written there. 3 squared is 9. So if we had that, then we could find the roots. But we don't quite have that, right? Because we need to account for this 2. But like I said a moment ago, we're allowed to do things to one side as long as we do it to the other. So let's give this a try. So let's say we move forward with this. Let's assume we're right, and making this change would help us. That's what we're doing. We're trying to find something that'll help us. So I'm just going to go ahead and write 9. That, since we've already pointed out, it's 3 squared. So I'm adding 9 here. I have to keep the 2 for now. And then I'm going to add 9 on this side too. So what I really want is just this by itself, because then I have these two factors. So the way to do that would be to say -2 on both sides. So then if I come up here and continue, that would result in x squared plus 6x. 9 plus 2 minus 2 is just 9. But on the other side, 9 minus 2 is 7. So if I refactor this back to what we had, x plus 3 equals 7. Well, x plus 3 times x plus 3 is the same thing as saying x plus 3 squared. If I take the square root of both sides, I get x plus 3 plus or minus square root of 7. Don't forget the plus or minus, that's important. Sorry, you can't really see it. And then if I move the 3 over, I end up with x equals -3 plus or minus square root of 7. And those are our two roots. x1 would be -3 plus square root of 7. That's our first root. And x2, the second root, would be -3 minus square root of 7. So we now have our two roots. And the way we did it was using what's referred to as completing the square. So the key was we acknowledged that we couldn't really work with the 2. There was no direct connection between the 6x. So we kind of worked around it by allowing ourselves to focus on the middle term. We broke it down and said 6 is 2 times 3. And if you look at it, if you think about it, what number added with itself would give us 6, that if we multiplied it together gives us a constant, and that is 3 squared, or 9, because then when we factored it and checked it, we ended up with the 2 3s. And so, this is always a good thing to do when you're answering a quiz question, is let yourself check yourself. Once you think you have the correct factors, multiply it back out and simplify it and see if you get what you thought you had. Then once we did that, we used the fact that we can manipulate both sides to get rid of the 2 on the left-hand side and move it over to the right, kind of. And then at that point, we just acknowledge that we have a duplicate, 6 plus 3. We rewrote it as being squared, took the square root of both sides, keeping in mind that it would be plus or minus square root of 7. And then we use that to get both of the 2 roots. So that's another way that you can go about solving a quadratic equation. Another thing I wanted to share that might help you, that kind of matches with this topic of completing a square, is a way to think about the physical meaning. We drew the graph, excuse me, but talking about completing the square, there's another physical meaning that you could think of for a quadratic equation like this. And let me first sketch a square, big square. So let's say this represented a piece of land. And let's say you were trying to figure out how big to make your house on the piece of land, but you hadn't really decided yet. But you knew you were going to make your house square. You were going to put it in the back left corner of your piece of land. So you knew that however big your house is, it was going to be x wide that way and x wide that way. And let's say that left over here, let's say 3, I don't know what would be a good number, 3 acres or 300 meters, something big like that. Let's say we have a big piece of land. And let's say you knew it was like 2 this way. And maybe you're trying to figure out how big a piece of land you need. Maybe you haven't bought the land yet. Well, if this is x wide here, this is x wide here, right? And if this is x wide here, this is x wide here. Well, let's look at this for a minute. If we're talking about area is one side times the other, right? So if this little region here is square, the area is going to be x times x, which is x squared. This region here is going to be 3 times x, which is 3x. Oh, I forgot to write the 3 down here. This region is going to be 3 times 2, which is 6. And then this region is going to be x times 2, or 2x. So if I wanted to write what the total area of this piece of land would be, what would it be? Well, I would sum up all the pieces of the little pieces of land that make it up. So what are those? It's x squared plus 3x plus 2x plus 6, or x squared plus 5x plus 6. And that's another way to think about this. And of course, that would equal the total area. Now, the standard form that you'll see is 0, right? But you can't have a 0 total area. All that means is a moment ago when we were doing the completing the square, and we ended up with that constant on the one side and a constant on this side, that's all that means is there was some number over here, but the number over here was slightly bigger, so that when we moved it over here, you still ended up with a 6 and 0 over here. So don't let that confuse you too much. but hopefully you can kind of see why we end up with the numbers we end up with when we multiply it out. And hopefully maybe this gives you a physical interpretation of what those terms represent, in addition to the one that we started off with, where you'll see it. Another example is you'll have an arc. And then the last thing before I wrap up is I promised to also point out the y-intercept. Well, you have some equation, say y equals x squared plus, or I guess I should write that as a minus since it's below. Let's say that's 1, so minus 1 or something. Then the way you find the y-intercept is very simple. You just plug in x equals 0. So if this was 0, that would give you y equals -1. Which, let's say that's what that is. Let's say that's -1. So if your teacher ever asked you what is the y-intercept for this equation, and they gave you the equation, that's all you have to do for that. So hopefully this has helped you some. And then of course, wrapping up the general form with the quadratic formula. Hopefully you've discussed that in class. I'll write it here just as a final step. And while I'm writing it, I'll just say that the quadratic formula is simply a general form of what we've been working through. If you start with that general ax squared plus bx plus c equals 0, where a is not 0, then you can do some of the manipulations that we've been doing in a more general way and show that the quadratic formula is what you end up with. And I'll just write it here. And that's basically how the quadratic formula was derived, is using these kind of manipulations to look for the roots. And when you do it in a more general form, you end up with the quadratic formula. And just like when I was completing the square, I ended up with that plus and minus. When you do it this way with the more general case, you also end up with that. So you can kind of think of what we did in that completing the square example as a specific case of this. And then the more general quadratic formula is they assume you have all the terms. And then one of the things people trip up on is they'll forget that you have that plus and minus. So don't lose sight of that. So this would give you two x's, x1 where you use the plus, and then x2 where you use the minus as well. Well, I hope this has been helpful. Again, in closing, if you have questions after we've wrapped up, you can either come to our Facebook page, it's just Facebook/TutorTonight, or you can come to one of these locations. We have a Twitter account @TutorTonight, an Instagram, TutorTonight, or you can go straight to the website, or you can download our Android app, and if you have a quick question, anyone, even another user that has installed the app, might have the answer you're looking for, so you can post a question there, and they can, anyone that has the app can maybe send you a quick answer. Well, thanks for tuning in. Check out our Facebook page. We'll be posting announcements when we plan on doing these and what topic we'll be discussing. Some nights it'll be algebra, sometimes it'll be other topics. And so we'll try to post an announcement ahead of time, so if you think you might need some help, you can plan on tuning in. All right, thanks a lot. Bye-bye.